பொருளகத்தின் பொன்வணக்கம். பொருளகத்தின் பொன்வணக்கம். விழியத்தை பாருங்கள், நுட்பத்தை நுகருங்கள். பொருளகத்தின் பொன்வணக்கம். பொருளகத்தின் பொன்வணக்கம்.
Yeah, getting back, so I was talking about, let's reiterate to our the first question that we posed, then what exactly is data science now? So as of now, if I give you a recap, we spoke about why we are talking about data science, what exactly has changed, and the reason that we are seeing a boom in data science is because of, first of all, we have access to a lot of data. Second, we have powerful softwares to do something extraordinary with this data or on this data. Third, we have powerful computers, powerful GPUs, powerful machines, which has the power to process this data to do something extraordinary. Because of these three things, essentially, we have seen a lot of use cases in almost every domain. So be it computer science domain, information technology domain, life sciences, pharmaceuticals, or automation, or mechanical engineering, automobile, or space science, or anywhere where you will see data science there, right? Every place we have the requirement for data science applications, and because of that, we have requirement for data scientist, right? So again, if getting back to the question, and now I'm going to define what exactly is data science. So data science is actually on a very broader level, it's a mixture of three essential things. The first thing is the tools, not exactly computer science, but the tools, some of the tools which are essential for you to understand data science, which comes from the domain of computer science, right? The second is the maths and statistics. So not everything, it's not like that you should be a very extraordinary mathematician or statistician. Rather than there are again few concepts in maths and specifically in statistics, which you should know, which makes you understand the data very intuitively. So you should become very intuitive towards data. So whenever a data set is provided to you, you should be able to understand what exactly is going on. You should know what kind of statistical analysis I can do so that I can pinpoint the overall understanding of this data. Once you have this understanding of the data, then you can build something on it. You can either predict something or classify something, or you can do something extraordinary on it. The third essential thing is the domain knowledge. This is very, very important, because it's not the case that data scientists are not those people who work on something general. They work on something very, very specific. So let's say if you become a data scientist in a company, that company will be working on something very, very specific. That company could be designing a software for a car to make it more driverless, right? Or it could be a company which is designing software or integrating AI-based technology on rockets so that it can gather the data automatically, or do the pathfinding automatically. It can be a company which where you are analyzing the data of a viral infection, and then you should be able to tell what is the life of this virus and how I can create a vaccine or something like that. So you can see the use cases are very, very specific, and for that you should have the domain knowledge of that particular use case. This is where the people from various backgrounds come. So again, it's not the case that you should be only coming from computer science, or you should be a mathematician to become a data scientist. Even if you're coming from some other background, let's say you are a mechanical engineer or civil engineer, or you are coming from life science, or you are into sales, or you are into commerce or accounts, you all of you can understand the data science by learning few technologies of computer science and mathematics and statistics and implementation part, and then you will become extraordinary in your domain, right? Because you will have a unique set of skills. First of all, your own domain knowledge, and then you have learned few tools which makes you understand the data in your domain, right? So if you are coming from financial domain, you have experience of 5 to 10 years in finance. then you can, and once you have understood the data science part, then you can work in fintech. There are many companies who are using AI to do something good or maybe predicting the stock prices or anything. So domain knowledge is very, very important. That's why this becomes a highly interdisciplinary domain. So data science is one of the most interdisciplinary domain you can ever see. It doesn't derive from computer science. It doesn't only derive from mathematics. It derives from a lot of other fields, right? Now, to understand data science, there again on a broader level, there are other things which you will be, if you want to learn data science, if you want to get into the learning part, there are few things that you should be very good with in, on a broader level again to understand the data science. For example, first of all, again, statistics, big data analytics, which is like you should be able to handle massive amount of data because nowadays the data is massive, right? Machine learning. Machine learning is very, very important because you should be able to build something, some algorithms which can use data to do something on top of it, maybe predict something, classify something, or anything like that. Data mining, this is the most important part because although we have access to a lot of data, it's scattered all over the internet, right? And getting the access to a very clean, good quality data is like very, very difficult, extremely difficult. So once you get into a company as a data scientist and you start working as a data scientist, you will see that majority of the time you'll be working on data acquisition, cleaning and processing, and then understanding it. 70% of the time, to be honest. 30%, once you have done this, the 30% part will only be to build some model on top of it. So majority of the part you will be spent because the data is massive and it's unclean, it's unstructured. So you have to make it, you have to clean it, process it, structure it, and then come to a place where it is your data has become mature enough so that you can do something with it. And the artificial intelligence, right? So artificial intelligence, I'll talk about artificial intelligence also, but it's a way of inducing intelligence to a machine. Right. So you want to make a non-living thing, which is a machine, intelligent somehow, intelligent like you. Should be able to mimic a human cognition. You should be able to think like human, but in a very larger scale. You should be able to process like human, but in a very larger scale. So we can do something extraordinary, but our limit is very less, right? But a machine, if can mimic the human intelligence, it can process a huge amount of information with the same intelligence. Although till now machines are not able to mimic the 100% of human intelligence. We are more intelligent. You should feel proud of it. But the amount of data or amount of information or amount of thing it can do, that is beyond us, right? So we can process data our naked hand or manually, but we are not scalable. But machine can do it within milliseconds, a lot of things. That's the huge difference, right? Now, if you want to get into this career, if you want to set a foot into data science, irrespective of whatever you want to become, you could become data analyst, you could become data scientist, you could become machine learning engineer, AI engineer, business intelligence officer, right? There are a lot of opportunities within the data science, right? But in general, if you want to get inside the data science, what are the things that you should be learning to kickstart your career? Okay. So the first thing is the type of person that you should become. We call it T-shaped. So whenever we take interview or we would like to recruit someone, we look for someone who has a T-shaped of skill. What do I mean by this? So the first thing is that you should be having a cross-discipline expertise. So let's say if you want to become a data analyst. So it should not be the case that you only confine yourself to the analysis part and you will say that, okay, let's say anything related to machine learning and AI, you say that I don't know, or anything related to deployment, you should say, no, I don't know. Rather than you should have at least a basic understanding of it and you should be able to take care of it if required, right? So that's what recruiter is looking at, a person who almost knows everything, but on the same time has a very good understanding of that, his or her particular domain. So if you are a data analyst, you should be extraordinary in the data analysis part. But on an overall basis, you should know the whole data science life cycle. You should know how to acquire data. You should know how to pre-process it. You should know how to do the exploratory data analysis, statistical analysis, and get the insight out of it. You should also know how to present your insight. Then once you have done this, you should be able to build some model on top of it, or to either predict, classify, or generate something. And then you should be able to deploy it on, let's say, some cloud-based services, AWS, Azure, or Google Cloud, anything. So you should know all these things, right? But let's say if in your domain, let's say if you are a data analyst, you should be extraordinary in that place. Once you get the data, your analysis is so pure and your quality of your analysis is so good that the insights that you are getting from it are very useful for the company or very useful for you. Let's say if you want to build something on your own. So if such kind of skills you have, then any company would like to recruit you. Now let's take the scenario of like what exactly current companies are doing, where exactly you are working. Let's say if you are placed as one of these key roles, where exactly you will be working. So let's take the role of data scientist. So the current scenario is, let's say you are hired as a data scientist, you'll be working on two fronts. The first front is that you will be working very close with, you will be collaborating with the domain experts to work on the idea level, right? So again, depending on the size of the company that you are working, domain experts could be anyone. So if the company is a startup, domain expert could be the stakeholders like CEO or CTO of the company. If it is a big product-based company, then there is a separate research team where domain experts could be senior data scientist or senior AI engineer, and you will be working with them. And with them, you will be working on conceptualization of the product that you are trying to build or the feature that you are trying to build. So that's why there is a scientist with data. So data scientist doesn't mean that you should hold a PhD degree or you should always hold a master's degree, or you should be a scientist. Rather than you should think like a scientist, or you should think like a scholar. You should have the daring behavior or willingness to come up with an extraordinary idea or come up with a very weird idea which can actually change a lot of things. So this is where you will work on the conceptualization or idea level domain. And then you will get to a point where your idea becomes so mature that it can be implemented. Now, this is where the second front comes. So in the second front, you will start working on the idea and try to implement it. So maybe your idea is to an application which can take any language, and once you speak it, you can convert it, and then the application will speak that language in that particular accent. It could convert also and speak it in that accent. So let's say if I'm speaking in English and I want to convert this to Tamil, the application will convert it within very fast, and then speak it also in Tamil accent only. It should not be English accent in Tamil, right? That becomes very weird. So if you're able to do something like this, this becomes a product, right? So now your part comes where you will be implementing it. Once you have implemented something like this, the next thing is you will be working with the app development team or the DevOps team to integrate it with the application. So it may not be the case that whatever feature that you are building is the only feature that your application has. Your application could be a very huge application which does a lot of things, and you are building a single feature, an AI feature, to integrate it with the application. This is where you will be working very closely with the app development team to integrate what you have built with the application, and maybe even deploy it on, let's say, wherever your application is. Usually nowadays, we don't have standalone applications. The applications are always SaaS services which are deployed on cloud-based services like Azure, AWS, or GCP. So this is where also you'll be working with the development team to deploy it and then make it live, right? So again, on a very broader level, this is where you will be working. Okay. Now, how to become data scientist, right? What are the things you should know? What are the things you have to learn? And what is the path that you have to take so that you can smooth it? It's not always smooth. It's never smooth, right? There will be hiccups, but at least you can make it easy for you to, or at least not exactly easy, but rather than a step-by-step process so that you can get to that point. So the first point is, irrespective of wherever you are coming, irrespective of how scared you are, but you should know coding. You have to learn coding, right? Many of you may not have touched coding ever. Many of you are maybe scared of coding. Many of you have used coding, but now have lost the touch of it. But now is the time, if you want to get into data science domain, if you want to become data scientist, for example, you should become an intermediate coder. I won't say exceptional coder. You don't have to become a software engineer, but you should be intermediate coder where you should be able to implement the idea. Now, to do that, I'll give you a brief example. There are multiple ways to do that. There are several programming languages which you can choose, right? Now, on a broader level, the programming languages are divided into two categories. First category is the lower level languages. Second category is the higher level languages. So the lower level languages are those programming languages which are kind of very close to the computer. So stake languages are as a communication thing which we use to communicate with computer, right? We give instructions in terms of using these languages, and computer can understand these instructions and does the instruction, executes those instructions. Now, lower level languages are those languages where if you have built something or if you have written some algorithm in these languages, it's very easy for the computer to execute it. By easy, I mean computer takes very less time to execute it. They're very fast with these languages, and it doesn't require a lot of effort for the computer to do that. I mean, memory is also they don't take a lot of memory also. So these are lower level languages, but the downside is that you have to put a lot of effort to implement something. So, for example, if you are using C++ or C, you have to write everything from the scratch. A lot of lines of code you have to write, and the syntax is also very difficult. It is more machine oriented. And then once you have done that, then once you have written your code, then to execute it, computer doesn't take a lot of time. Computer has not to put a lot of effort to execute it. Now, the other set of languages which are high level languages are those languages which are less closer to computer but more closer to human. So by that I mean, for you to understand these languages or learn these languages or write something in these languages, it's very intuitive. So one of these languages is Python. So Python is very close to English-like language. So many things you will see are very, very intuitive. Once you see that, you will be able to understand what exactly is going on. Plus, a lot of complex operations you can just write in single line. There are so many powerful libraries. You don't have to worry about what is going inside. You just write this line and Python will take care of it. But on the same time, the computer has to put a lot of effort to execute those things. So it's time consuming for computer. Now, again, getting back to our first discussion that we spoke about, why there is a boom of data science, right? And one of the reasons I said that we have very high-end hardwares. So you being a data scientist, you don't have to worry about why computer is taking a lot of time or anything, because computer won't take a lot of time because we have a lot of, we have high-end hardwares. So we being a data scientist, we don't have to worry about implementing a high quality code or implementing everything from the scratch very efficient. Rather than our main aim is to work on the idea level, to work on understanding the data, to work on getting the insights from data, and then using the languages like high level languages to do things very easily, right? So we don't want to spend a lot of time on implementing stuff. Rather than we want to spend time on idea level. We want to come up with an extraordinary idea which can do something useful for us, useful for our target audience. And then we'll use Python-like language, which is very, very intuitive, to almost automatically implement everything. You can genuinely automatically do a lot of things where in very few lines of code you can build something extraordinary, and you will see it in many places. Right. So again, by all this conversation, my point that I was trying to make, although you have to learn coding, you have to become intermediate coder. But because we have languages like Python, you can become a very good coder in very less amount of time with very less effort also. You just have to be very sincere. That's all. Now again, getting more into Python, because most of us are scared of coding, right? We think like that we never coded and we have to compete with people who have already coded. How it is going to do? I won't be able to do. And the initial learning curve is always kind of steep. You might feel demotivated initially, but still is very simple. Okay, extremely simple. I'll tell you one example how simple it is. So on the left side, I have a Java code through which I'm just trying to print hello world. You can see it's kind of complicated, and you don't many of you won't even understand what exactly is going on the left. On the right side, where the Python implementation, it's very intuitive. It's written print and inside the bracket hello world, and that's all. And this is one of the basic examples. There's so many examples that you will be seeing where Python, you will just use a single line or a very small phrase which will do something extraordinary. Whereas such things, if you try to implement from the scratch, it will take a lot of time. So because of it, learning Python becomes very easy and you don't have to worry about the nitty-gritty of it. The second thing is that why we are going to choose Python is Python has, first of all, Python is open source. By open source, what I mean is you can use Python to build anything and you can make it commercially available without, you don't have to worry about the license. That's what open source means. Not just this, you can use Python, change the code of it. Python code is available on the GitHub. If you are extraordinary coder, you can add a new function to it and they will accept it. If they accept it, then you can contribute to it, right? So that's what open source means. Anyone can come and contribute it. I mean, it's just that the contribution should be legitimate. So because of it, there are so many powerful libraries built by powerful companies, right? So you will be using these libraries to again build something useful. For example, some of the libraries are NumPy, a very exceptional libraries to do statistical analysis. Scikit-learn to do machine learning. Mostly you will use it to implement machine learning tasks, machine learning or train machine learning models. Pandas to do data analysis and Tableau data, especially. Matplotlib for visualization. TensorFlow to implement deep learning or machine learning tasks. PyTorch again to implement deep learning. So these are very powerful libraries built by top coders or top researchers. For example, PyTorch has been developed by Facebook. TensorFlow is also it's an open source program, but it was developed by top people who are into AI, right? So and there are so many other libraries which you will be seeing. And because of this, the community is also very strong. So if you face any problem at any point of time, if you're getting an error, you're not able to understand, go just Google it and you will get the answer. It's not possible that for a particular question, for a particular error, you will not get an answer. That is not possible. It's impossible. And if it is happening that you have got some error, for that you are not able to get an answer, it means that you are implementing something very new which no one has done, which is again very rare because mostly everything has been implemented. So that strong Python has become. Okay, now let's talk about, so this is where I wanted to give you motivation towards programming, that too with Python, because this is what you will be seeing. If you want to become data scientist, mostly you will be seeing Python as a language, right? That's the trend. 70 to 80% of the data scientists are using Python now in this particular 2023 I'm talking. Now let's take the current trend of data scientists. Who actually are becoming data scientists? What kind of profile they are having, right? So the statistics is kind of old. It's 2017 statistics, but we'll try to extrapolate these statistics to think about what kind of trend is going on. So there was a survey done by 365 magazine. And what they did, they took the profile of 500 people who are on LinkedIn and who have written that they are working as data scientists. And these 500 people are those people who are working in Fortune 500 companies. Okay. So these are legit data scientists working in Fortune 500 companies, and they have extracted the LinkedIn profile of these 500 people. Okay. So don't worry about the first 4 or 5 statistics. The second last and the last statistics is important for us. The first thing is that most of them said that they were either using Python or R. At least 50% of them said that Python, 50% said R. But this trend in 2023 has changed. 70% will say Python and 30% will say R. The second thing they said that most of them were having some kind of master degree or certificate, or not just degree, Either they had master certificate, some master program they have done, or may have master degree. Very few had PhD degree, right? And most of them were bachelors, but they had done some master course in data science. This again the statistics of what kind of tools they were using. So majority of them were using Python as the programming language, right? This trend has changed now. In 2023, see, the top language is Python. I'll show you. I guess I have the data also. I'll show it. And the other languages, which is SQL. SQL is also very popular. MATLAB now again decreased because MATLAB is not open source. It's a licensed version. So even 90% is not using in 2023. Okay. Now, the second statistics which is very useful is this. They try to find that people who are currently working as data scientists, what these people were doing 2 jobs before and 1 job before. Okay. So the first statistics is what these people were doing 2 jobs before. So 1 job before and the second job before, right? 2 jobs before, what exactly were their profile? So they found out that very few were actually data scientists. To be precise, only 14% were actually data scientists, or let's say even IT specialists or even analysts. Majority of them were not even into the information technology background. You forget the data science only. Many were from academia, some were intern, consultant, and 25% had no previous position, fresher, right? 1 job before also they saw, and then again they saw only 36% were working as data scientists, right? Again, only 7% was IT specialists. So if I aggregate these two also, more than half were not working as data scientists. They were as some other domain. Either they were not having any previous domain, or they were into some other position, maybe consultant or any other position. Now they went into the deeper level, and then they found that very few people knew computer science. Only 20% knew computer science. If you take the statistics and mathematics also, 20 plus 19, only 39% of people knew this, and only 13% knew actually data science. Other than that, either they were from economics, social sciences, or natural sciences, or core engineering, like civil or mechanical, or maybe some other places, maybe accounts or fintech or any other places. Again, it shows that how highly interdisciplinary it is. It's not like that only computer science is dominating. Although you should learn few of the concepts from computer science and statistics, but the people who are getting into the data science are not computer scientists or from computer science domain, or those who have already only done bachelor's or master's in computer science. That is not the case. The other interesting part, they saw that 40% of them had some kind of, again, certificate, okay, that too attached with their LinkedIn. So this is what they saw, which is attached in their LinkedIn resume. Some of them they didn't even attach, right? And on an average, they had like 3.3 certificates. So everyone had at least 3 certificates, some kinds of certification they have done in relation to data science. Okay. Now the other other statistic that I would like to put is what are the domains where actually data science is being exploited. Again, this data is kind of 2020 only, but again, a lot of things has changed in last 2-3 years also. Now, apart from India, if you see other domains also, it's not the case that only in information technology you're seeing a lot of use cases. People have started exploiting industrial domain, healthcare domain, financial domain. Especially in healthcare, a lot of data science applications are there. Extraordinary. Because if you see currently, even in India, a lot of things are digital but manual. So, for example, if you see the policy, how the policies are being evaluated and how your policies are being claimed, it's still a lot of manual things are being involved. So if you take this domain only, you can find a lot of use cases where you can build AI-based technologies to do something extraordinary. I mean, you can process thousands of policies within a few minutes, and which can increase the overall productivity, right? So the whole point is that there are several use cases in every domain, and you can exploit these use cases and build something. It's not the case that you should only think about going into a particular company to work as a data scientist. maybe you can start your career like this, but you can become an entrepreneur. You can build something on top of it. Most of the people are doing like this only. They are building something on their own. They work in a company, but on the same time they try to build something on their own, and eventually they become an entrepreneur. They start their own career. Right. This is what we have. This is the paradigm shift we have started seeing, especially in India. In last year only, we saw 240 companies incubated, which is huge, right? And it's not like these companies are just only some two people came and they say that we are playing startup. No, these are serious people that they are actually working. They're coming from very good set of background and experience, and they are trying to build some. They have some product, right? So you can be also something like that. Now let's talk about some of the cool implementation and cool application that we have been seeing, which is motivating us to get into data science, get into artificial intelligence, machine learning, so that we can also build something like that. The first is that you all have seen is the speech recognition related activities. So one is that you in your mobile, you have multiple speech recognition. For example, if you're an iPhone user, you might be seeing Siri, you can see Alexa. And actually it can do a lot of things, right? Once you talk to it, you can generate a lot of information, you can get a lot of information, you can extract the precise data that you want, right? And there are so many cool applications that we have started seeing in this direction. One such application I'll tell you. So there was a research done by MIT people where they were able to reproduce or create a model which will so it was an application where you will just speak for a few minutes, not just few minutes, few seconds actually, and it will be able to generate your face. Now this is something very extraordinary, right? Just by using your voice, they were able to generate the face of the person. Now this is so extraordinary that they were, I mean, if you think the foundation part of it, it means that everyone's voice is actually unique, which we never thought. That's why you are able to, I mean, and the way the voice changes, you can actually predict the age of a person also. And that is again intuitive. Once I'm sharing this information to you, you might be thinking at this particular stage that actually this is true. Once a person becomes old, the voice also changes. There are so many things, the pitch and the intensity of the voice, it changes. If the person is very young, the voice, again, the modulation of the voice changes. If the person is in his 30s, 20s, the voice has some kind of correlation. Using data science, you can find this correlation, and they were able to generate the face of the person, which was very, very accurate, right? So again, a very cool application that people started building. Nowadays, what we are seeing the large language models and the application of it, whether in the NLP or computer vision. So one example is DALI kind of application that you might have seen, where you can generate something just by writing a phrase. So for example, if I write a photo of astronaut riding a horse, which is again very weird, it's like a phrase elephant in the room, right? But it can generate, and it looks very legitimate also, that there is the astronaut is riding a horse, right? That too in the space, right? So AI is so capable, these models are so extraordinary, so capable that it can generate something new also, something that we can only imagine. We cannot realize it, but and if we want to create something using the traditional Photoshop, it will take a lot of time, but the generative models can do it without less any effort. Not just this, it can write some complex code, which again, if we had to write from the scratch, it will take some effort. For example, if I want to write a code which can train a neural network from scratch and do something, it can do it. You can just use a ChatGPT to solve a lot of programming exercises also, and it will give you the code, right? So extraordinary it has become. This is the thing that I was talking, that you can see this particular video where they were able to talk about audio to face. It can talk in any kind of languages, that too in that particular accent, which is very important. So you can always use speech to text, and then use this text to speech again, and then translate it and speak it. But mimicking the accent is something which is very much required, right? So I can always speak in Hindi, right? I can translate this Hindi to Tamil. But let's say if I ask an AI to just read, or ask a bot to read this Tamil, the accent will not be very good. You can always say. But if you can create a machine, or if you create a bot which can speak in the exact Tamil accent, a person, let's say, looks like that bot is mimicking a person from Tamil Nadu who is speaking this Tamil, then this becomes extraordinary. You cannot know the AI, whether it is AI or human. Okay.
Hi, I'm Diana.
Okay.
What?
Okay. The second, one more cool application which I feel very cool is in the terms realm of gaming. Right. So I would like to play a lot of games, and this was it's a kind of old game, around 2018 or 98 game. But now in the gaming industry, we are seeing the applications of AI or more. But this game, the name of the game is Detroit Becoming Human. The story of the game changes the way you play the game. Okay, and the ending of the game also changes the way you have played. So the AI engine that they have built was able to take the decision in the accounts, and based on decision, it will change the storyline and even the ending. So this was something extraordinary. And then after that, many gaming companies started building this AI engine, which can do something extraordinary with the overall storyline, with the characters, with the narratives, with the environment, which is again very good. In the fintech GUVI, you might have seen fraud detection, risk detection kind of things. So based on the type of transaction you are doing, based on the frequency of transaction you are doing, based on the number of times you are trying to log in, the bank can actually tell whether you are a legitimate user or you are trying to do something fraud. That's why you will see that CAPTCHA starts becoming weird. It starts behaving weird, right? Sometimes you will see that you are trying to log in and something happens, you try to log in again, and something happens and you are trying to log in again. So within few seconds, if you do this, the CAPTCHA starts behaving very weird. It starts giving you lights and everything, and makes your process very hard, because they want to know whether you are actually a human or not, because the type of activity that you have done looks like you are some kind of bot who is trying to get into the machine, and then it triggers the overall risk management or risk assessment of the machine. So AI has become smart, and the fintech companies, even especially the credit card companies, they've started using it to detect the fraud, right? The second part is the driverless car, which we have been listening to. It's many confined environment is actually a reality, but maybe we would like to see it in the real reality. There may be roads of India, which is, I don't know, even possible or not. But this is where, again, because you have to build a machine which can implement things very fast, very efficiently, because in roads, anything can happen within milliseconds or seconds, right? So the AI should be able to take the decision, right decision, conscious decision, like human, right? So this is where the extraordinary realm of AI comes, right? And I would like to end my presentation on this part, that at this era, data has become the gold mine. There was a time when algorithms were gold mine. You have to build extraordinary algorithms to do something extraordinary. Nowadays, we have those algorithms. We are just improvising those algorithms to the realm of, so that it can be used. It's scalable and can be used for huge amount of data. But now the main idea is to use huge amount of data to do something extraordinary. So data has become water, to be honest. If you are able to gather the right data, label data, process data, clean data, then you can do something very, very good with it. If your data is biased, if your data is not good, then the whole thing can crash. There was a case, I'll tell you. So in I guess Seattle or somewhere, the police built an AI machine where it can, given a profile of a person, it can tell what is the chance of that person doing a robbery or doing a crime. I don't know what kind of data they use or what exactly they use. It was biased towards the African origin people, black people, right? And that created a lot of fuss. I mean, with 70% more weightage to the African origin people, it would say that this person has more chances of committing a crime as compared to the white people. So they had to trash this whole, reload that whole application that they have built and remove that everything, because you cannot have a biased data, right? Many AI that people have built had this biasness also. If you ask that what usually women do, it will say that women either work in kitchen or they work in gardening or they take care of the kids, again biased, right? And if you ask what women do, men go to office, men do these kind of work, men do labor kind of work, again biased. So these are the things which if you go on chat GPT and try to ask, it will be very careful. It won't say these biased things. So these are the things which we have to take care. One example I gave, a biasness, which is very, very important. So it all depends on how you have used your data. The first set of data, or the data which you have used to train your model, or from where you are trying to get the insight. If it is good, you will be able to get the good result. If the data is not good, then whatever algorithm, how efficient you write the code, everything is going to crash. Okay, this is where I'm going to end, but I'm purposefully ending at this stage because I would like.
நாடிய சொந்தம் நான் காணும் பந்தம் எங்கும் பேரின்பம் நாளொரு வண்ணம் நாம் காணும் எண்ணம் ஆனந்தம் காற்றினில் எங்கும் என் அன்பு செல்ல ஏங்கும் என்னாலும் ஏக்கம் உள்ளாடும்